system of linear equations continuous. For example, given 2x minus 1y plus 3z equals 3. X minus z equals 1. And minus 3x plus y equals minus 3. Okay. Now, solve using inverse problem. Inverse matrix. Number 1. Find inverse. Recall that to find inverse of a matrix, a square matrix. Now first we put a coefficient matrix, coefficient number before each variable. 2, minus 1, 3, 1, 0, minus 1, minus 3, 1, 0. Coefficient matrix. And X, a known matrix in column, not in row. X, Y, Z. In column because we have product up to multiply up to matrix, row, column. 2x plus minus 1y plus 3z, row and column. And B, right hand side matrix, 3, 1, minus 3. Okay. Now that column, not row. And we have A, X equals B, equivalent to pre-multiply left hand side. Do the same thing, pre-multiply. We have A inverse here, delete A, X, A inverse B. Okay. Now, in this question, we have to find A inverse, not use calculator. First, we have to find determinant of A. For this, you can use calculator. Mode number 4. Define matrix number 1, mod A. Mod A. Number of rows, 3. Number of columns, 3. Row, 3 rows, 3 columns. 2 from the left to the right equals minus 1 equals 3 equals 1 equals 0 equals minus 1 equals minus 3 equals 1 equals 0 equals AC. Okay. You can see here X inverse. Sorry. Here we compute determinant of A. Option determinant number 2. That option number 3 mod A equals 2. Okay. Different from 0. So A is invertible. different from 0, invertible. Now C11 cofactor. C11, number minus sign, minus power, row plus column. Okay. And minor, delete row 1, column 1. Delete. Delete row 1, delete column 1. And we have 0 minus of minus 1, 2 minus sign is plus. C12 minus 1 power row plus column. Okay. Delete row 1 and column 2. Row 1, column 2. 1 minus 1 minus 3, delete column 2. Okay. 0 minus 3 minus is plus 3. C13, number minus signs, minus 1 power row plus column. Delete row 1, column 3. We have 1, 0, minus 3, 1, 1, 0, 4 minus sign, 1. Okay. Now C21, minus 1 power row 2 plus column 1. Delete row 2, delete column 1. Minus 1, 3, delete row 2, column 1. 1, 0. 0 minus 3 minus plus 3. Okay. Now C22, number minus sign, row plus column. Delete row 2, delete column 2. 2, 3, minus 3, 0. 0 minus of minus 9 plus 4 minus 9. C23, 2 plus 3. Delete row 2, delete column 3. Row 1, row 3. Okay. Two minus 3 minus 1 minus 1. C31 power row first and plus column. Delete row 3, delete column 1. Row 3, column 1. Okay. Row 3, column 1. Main diagonal 1, sub diagonal 0, 4 minus 1. C32, row 3 plus column 2. Delete row 3, column 2, row 3, column 2. Okay. Main diagonal, minus 2, minus subdiagonal, minus, minus, and minus, plus 5, and C 3, 3. Row plus column. Okay. Delete row 3, column 3, main diagonal 0, row 3, column 3, subdiagonal minus 1, 6 minus. So we have inverse of A, 1 over determinant of A, 2. Okay, determinant of A, non-zero. C11, C12, instead of writing in this position, but we have T transpose. So we write here C12 instead of writing here. We write here C13 here becomes 2 here. C22, 21, 22, 23, and 31, 31, 32, 33. Okay. Instead of writing row by row, we write column by column because we have transpose. Do you understand? Instead of writing row by row, we write column by column because transpose. And you can use your pocket calculator to check your result. Okay. And now x inverse of A multiplied by B is okay, and you can compute this row, column, inner product, row, column, here, row 2, column 1, here, and row 3, column 1, here, row 3, column 1, and you will have the result for x and y and z. Do it at home as exercise. Now method 2. Method 2. Gaussian elimination. Okay. You can write augmented coefficient matrix 2s minus 1, 3, 1, 0, minus 1, minus 3, 1, 0. What is 3, 1, Okay, minus
3.
minus 3. Okay. Now we have to transform this number into 1. 1 means 1x, 1 here. We exchange two rows. Row 1 exchange row 2 to have 1. Number 1 here. 1, 0, minus 1, 1. 2, minus 1, 3, 3. And remain third. Okay. And now we use this number to delete this and this. Means 0x, 0x, 1x here. So we have to transform equation 2 becomes to row 2 using row 1. The row which contains pivots. Minus 2 row 1. Minus 2. And transform row 3. Row 3. Plus 3 row 1. Plus 3 row 1. Okay. Remain row 1. Transform row 2. Minus 2. Minus this. Minus 2 of this. 5. Minus 2 of this. 1. Okay. And transform row 3. Plus 3 of this. 0. Plus 3 of this. 1. Plus 3 of this. 3. Minus 3. Plus 3 of this. 0. Okay. 1x, 0x, 0x. Now we want number 1 here means 1y. We transform row 2, which contains this number. It comes to minus 1, 2. Minus 1 row 2. Change the sign. Minus 5. Minus 1. Remain. Okay. We want number 1 here. Means 1 second variable. And we use this to delete this number. We transform row 3 becomes to row 3 minus row 2. Minus 2 minus 1. Okay, minus of this 1. Now we want this number becomes to number 1. Means 1z. Third column is a third variable z. We have to transform row 3 becomes to row 3 over 2 divided by it 0, 0, 1, 1/2. Okay. Remain first row. Remain second row. And transform row 3. Then we use this number pivot to delete this. Okay. Similarly, we transform equation 1. Transform equation 2. Row 1 becomes to row 1 plus row 3. Okay. And row 2 which contain this number becomes to row 2 plus 5 row 3. Okay. Remain row 3 and row 1 plus row 3 plus 3 over 2 plus 5 0 plus 5 plus 5 plus 5 plus 5 of this. Okay. So easily you can see the result 1 has 0 y 0 z. So has this is the number right inside. One of second row column means 1y. And 1z. Okay. If I have any mistake, you can check at home. Okay. Step by step. Now we have a very, very important theorem about solutions of a system theorem. Rank A, number of non-zero rows of A after reducing it into echelon form equals rank A upper bar equals n number unknown and we have unique solution. Unique solution. If R equals R upper bar equals k less than n. We have infinitely many solutions. Infinitely many solutions. And case number 3. There is no solution. No solution. We have 3 cases. Unit solution. RNA upper bar equals number unknowns. Case number 2. RNA equals RNA upper bar less than number unknown. Infinitely many solutions. And case number 3, less than RNA less than RNA upper bar, no solution. Now I consider some examples for 3 cases. For example, after transforming a system into echelon form, for example, okay, three equations, four equations, sorry, and 3 columns means 3 variables, 4 equations, 4 rows, 3 columns left hand side, 3 variables. This is of the form echelon form, not reduced echelon form. Echelon form pivot 2 is not a 1. Pivot minus 1. Okay. We have echelon form. Pivot. Non-zero. First non-zero from the left to the right. Okay. Rank A from here to here. Coefficient matrix, left hand side. 0 rows. I have 1, 2, 3 non-zero rows. So rank A, 3. A, left hand side. And rank A upper bar. We have augmented coefficient matrix. We have from here to here to here, non-zero. So 1, 2, 3, 4 non-zero. 4. This is 0 row of A, but this is non-zero row of A upper bar. So we have rank A less than rank A upper bar. Implies that no solution. Okay, you can see 1, 0x plus 0y plus 0z is 4. Incorrect. Okay, 0x, 0y, 0z is 4. Incorrect. Now consider this example. Rank number non-zero rows of A, left hand side, 0 rows, 1, 2, 3, non-zero rows, 3, and A upper bar, rank A upper bar is also 3, and 3 column for 3 variables x, y, z. Okay, compare this value. We have rank A equals rank A upper bar equals a unique solution. Okay, very clear. Now the case more complex. For example, consider this. Non-zero, first non-zero elements from the left. First non-zero element from the left. First non-zero element from the left. Okay, and this is 0 row of A. This is 0 row of A upper bar. Okay. On pivot are 1. On pivot are 1. And on elements of the same column of pivot and above here, above the pivot here, 0. This is echelon form, reduced echelon form. Reduced echelon form. 0 row at the bottom. On pivot are 1. And on elements in the column and above of the pivot are 0. Here. This is our reduced echelon form. Now, rank A. Rank A, left hand side. Don't count this because it's 0. We have 1, 2, 3. Rank A upper bar. Don't count this. We have 1, 2, 3. And number column of the left hand side. X1, X2, X3, X4, X5 equals number. Okay. The first column X1, the second column S2, column 3, column 4, column 5, and the right side number. Now we compute and we compared these values 5, find variable. We have range A equals range A upper bar less than n equals 3 less than 5 n. Okay. So we have infinitely many solutions. Infinitely many solutions. Now we write up. We have to find solution. Formula for solutions. Here. X1 corresponds to pivot. We have, this is a principal variable. Principal variable. Correspond to pivot x1. Here, x3 pivot, and here x5 pivot. Okay, principal variable, and the other variables are free. They can take any value. Free variables. Other variables. x2, x1, 2, 3, x4. Do you understand? Variable correspond to pivot are principal variable, and the other variables are free. They can take any values. So, the formula for solution x1 we have to solve. x2 free equals a arbitrary number. x3 we have to find. x4 b arbitrary, and x5 we have to find. We find x1 1 number, you can see this a number. 2 what? 2a, 2 x2, 2a. Move to the right hand side, minus 2a, and minus 3 x4 equals b, minus 3b. Move to the right hand side, change the sign, plus 3b. Do you understand? We substitute x2 the value a and move to the right hand side, minus 2a, and here x4 b minus 3b move into 3b. x2, x3 here, x3 number 3, minus 2 to what? To b. Move to the right hand side, plus 2b. Okay. x5 equals number Do you understand? Main principle. Variables correspond to pivots x1, x3, x5, and other variables are free. They can take any values. S2, S2, and S4, B. Okay? Now, let's see another example. 1, 0, 0, 0, 1, 0. Okay. First non-zero elements from the left of this row is here. First non-zero from the left of the row 2 here. First non-zero from the left to the right of row 3 here. Pivots on pivots are 1. And over in each column 0, 0. Reduce echelon form. Okay. Reduce echelon form. And the row 4, 0 row of 8, on elements are 0, and of A upper bar on elements are 0. So rank A 3, 1, 2, 3, left hand side. Rank A upper bar 1, 2, 3, left hand side. And augmented to the right. And number column 1, S1, 2, S2, 3, 4. Compare these values we have. Okay. So infinitely many solutions. Okay, and variables correspond to pivot x1 principle, x2 principle, and x4 principle, and free variable here s3 pivot principle, pivot. Now solution x1 equals number 3 what? 3a move to the right hand side minus 3a. x2 here, x2 equals number minus 5 what? 5 minus 5a move to the right hand side plus 5a, and x3 a, x4 here equals 0. forget. Stop here. Thank you.